Thanks for watching this video from Big D Soul. In this video we will be covering Hadoop components and importance of MapReduce. Quick view on Google's paper on MapReduce. Understanding MapReduce various logical steps. Exploring the word count Java program in detail. Few other facts about MapReduce. MapReduce is a software framework for easily writing applications which processes vast amounts of data in parallel on large clusters having thousands of nodes of commodity hardware in a reliable, fault-tolerant manner. In the Hadoop framework, HDFS and MapReduce are basic building blocks. HDFS stores the data in files, and MapReduce processes the data. It's a framework for massive parallel processing. Data is stored on hundreds of clusters and each cluster has thousands of nodes. It abstracts the underlying complexity, programmer can focus on their program, and the framework takes care of the details of parallelization, fault tolerance, locality optimization, and load balancing. MapReduce is also known as for paradigm shift. If you consider any RDBMS database functions, data is passed to function, function does the calculation and return the results. In MapReduce programming model, computation goes to data rather data coming to program. Processing takes place where data is. His offers network load reduction and faster computation. Remember, we are talking about petabytes of data. Before we get into the details of MapReduce, keep the basic fundamental things in mind. In MapReduce we define the input, it could be a text file, or could be a video input. We define map function, which breaks the input in smaller consumable chunks and makes the key and value pairs. Then the output of map function goes to reduce function, which does the aggregation. And finally we define the output. In the background framework does the rest. Let us spend 1 minute on quick overview on Mother of Hadoop MapReduce, the Google white paper on MapReduce. After finishing this video I would encourage you to download the white paper from Google research site. The paper published in 2004 with subject line as MapReduce, Simplified Data Processing on Large Clusters, published by Jeffrey Dean and Sanjay Mawad. The abstract says, MapReduce is a programming model and an associated implementation for processing and generating large data sets. Users specify a map function that processes a key/value pair to generate a set of intermediate key/value pairs, and a reduce function that merges all intermediate values associated with the same intermediate key. Many real-world tasks are expressible in this model, as shown in the paper. Programs written in this functional style are automatically parallelized and executed on a large cluster of commodity machines. The runtime system takes care of the details of partitioning the input data, scheduling the program's execution across a set of machines, handling machine failures, and managing the required inter-machine communication. This allows programmers without any experience with parallel and distributed systems to easily utilize the resources of a large distributed system. Paper tells about the programming model, and how it provides abstract to programmers, and powerful interface that enables automatic parallelization and distribution of large-scale computations. The programming model described in the paper as the computation takes a set of input key/value pairs, and produces a set of output key/value pairs. The user of the MapReduce library expresses the computation as two functions, map and reduce. Map, written by the user, takes an input pair and produces a set of intermediate key/value pairs. The MapReduce library groups together all intermediate values associated with the same intermediate key I and passes them to the reduce function. The reduce function, also written by the user, accepts an intermediate key I and a set of values for that key. It merges together these values to form a possibly smaller set of values. Typically just 0 or 1 output value is produced per reduce invocation. The intermediate values are supplied to the user's reduce function via an iterator. This allows us to handle lists of values that are too large to fit in memory. Important thing to remember is, input could be anything. It could be a structured data file, or a weblog file. Let us look at one example, of word count. The map function emits each word plus an associated count of occurrences, just one in this simple example. As you can see, input key to map is document name, while the value is document contents. The reduce function sums together all counts emitted for a particular word. As you can see, reduce function taking key as a word, while values is a list of count. The paper depicts the execution overview of MapReduce function. There is only one master, and multiple workers. Master assigns the task to workers. Workers splits the files, do the internal operations like sorting, merging results and passing the results to reduce phase. Reduce aggregate the results, and finally worker writes the results to file. Remaining paper talks about the MapReduce program, more details, and performance testing. Let us take two examples to understand the logical flow, and then we will deep dive one Java program to understand the MapReduce programming. Let us look at logical steps performed to get the count of car names from input data node. First, the data is split into multiple data chunk, then the mapping function prepares the list of key and value pair. Then shuffling and sorting happens. Now this input is ready for reduce function. Reduce will do the grouping and prepares the final results. Another simple example of word count, explaining twinkle twinkle rhyme word count. You can observe how May and reduce work in harmony to produce the results. Now we are going to dig into one sample MapReduce Java program. The objective of program is to count number of distinct words in each file. This program has two input files, are file 01 and file 02. Map program takes the input and starts emitting key and value pair. In this example, key is single word, and value is their count, which is 1 in the first map output. After the first map function, if required, a local combiner is applied to reduce the aggregate the same keys. Finally, a reduce function is applied to aggregate the data from different map functions. The output of map function is unique key and aggregated values. Let us try to understand the code for MapReduce. The code snippet is taken from Apache Hadoop website. Let's now focus on the class definition part. The data types provided here are Hadoop-specific data types designed for operational efficiency, suited for massive parallel and lightning-fast read-write operations. All these data types are based out of Java data types itself. For example, long writable is the equivalent for long in Java, int writable for int, and text for string. In the class definition, 4 parameters refers to the data type of input and output key value pairs specific to the map method. In our example, input is single line of text. The output from the mapper is of format word and numeric value 1. Here is the map function definition. We'd now look into each of the input parameters in detail. The first and second parameter refers to the data type of the input key and value to the mapper. The third parameter is the output collector, which does the job of taking the output data either from the mapper or reducer. With the output collector, we need to specify the data types of the output key and value from the mapper. The fourth parameter, the reporter, is used to report the task status internally in Hadoop environment to avoid timeouts. The functionality of the map function is as follows. Create a int writable variable 1 with value as 1. Convert the input line in text type to a string. Use a tokenizer to split the line into words. Iterate through each word and form key value pairs as Assign each word from the tokenizer, of string type, to a text word. Form key value pairs for each word as word 1 and push it to the output collector. Now let us look at the reducer function. The input parameters have same functionality as map function. Observe the key and list of values. The functionality of the reduce method is as follows. Initialize a variable sum as 0. Iterate through all the values with respect to a key and sum up all of them. Push to the output collector the key and the obtained sum as value. And finally let us look at the main class. First, creating a job conference object and assigning a job name for identification purposes. Then, setting configuration object with the data type of output key and value. Provide the mapper and reducer class names. Set the HDFS input and output parameters. Run the job. Now we are ready to execute the program. First compile the class and create a jar file. Place the files in appropriate HDFS input directory. Run the application using the following command. And here is the output by the MapReduce program. Aggregated word counts. Few facts about the MapReduce. Number of map depends on input data size, usually 10 to 100 per node. Set number map tasks, int, can be used to set it higher. The number of reduces for the job is set by the user via job conference set numReduce tasks, int. The right number of reduces seems to be 0.95 or 1.75 multiplied by number of nodes multiplied by maximum number set. It's legal to have 0 reducer if no reduction is desired. The Hadoop framework is in Java, but it supports the streaming, thus making it possible to write the MapReduce in other languages like .NET and C#. Usage of RDBMS for MapReduce is picking up. The Hive is available where we can store the data in RDBMS fashion, and fire SQL-like commands. Internally those commands are converted to MapReduce, and fetch the results.
Thank you very much for watching the video from Big D Soul. We are a small group of working professionals trying to make impact in big data landscape. Out of our hectic office hours, we devote weekend time in developing products and providing trainings. Hope you have enjoyed it.